Alright, so welcome again to another segment. So if you still remember, in my previous video I actually talked about these trigonometric identities, which we call as being Pythagorean identities. Now let's look at the solution to this question that I'm having there. It actually says prove the identity. So tan squared theta plus sine squared theta is equal to sec theta plus cos theta brackets and sec theta minus cos theta. So they want you to prove this identity. Now when it comes to proving these identities, you can either use the left hand side to show that the left hand side is equal to the right hand side, or you can use the right hand side to show that it is equal to the left hand side. Now what should be easier for you to pick up? Is it the left or the right hand side? So you need to look at the one which looks a bit complicated, can easily help you to look at the other one. So between the two, I can see that the right hand side is actually looks a bit complicated, and therefore I can use this one to show that it is equal to the left hand side. So let's start in this case by using, in this case, the right hand side. So according to the right hand side, I do have there it is actually sec theta plus cos theta close brackets, and again sec theta minus cos theta. That's what we have. So we can actually expand this one. So how is that going to be? So sec theta times sec theta will give me sec squared theta. Then sec theta times negative of cos theta will give me negative sec theta cos theta. Then again we can go to this one, cos times that one will still give me sec theta cos theta. Cos theta times negative cos theta will give me negative cos squared theta. You can see that this and that will actually cancel, and if you look at it this way, you're going to find that this gives you sec squared theta, then that is minus cos squared theta. Now of course we want to show that, so what we can simply do is that, remember here we have got sec squared theta, and if you remember from the identity, sec squared theta can actually be replaced by that. So I'll simply replace by 1 plus tan squared. Now here they are using theta, not x, so you maintain the letter that they are using. So in this case it will be theta, then minus, what about cos squared theta? If you look at cos squared theta, you can just take this to the other side, meaning that cos squared theta will be equal to 1 minus sine squared theta. So where there's cos squared theta, we can actually replace that. So this is what I would do, 1 minus sine squared x. Now of course you can just work out that, so it will be 1 plus tan squared theta minus 1, negative and negative will be positive, so that will be sine squared theta. So you maintain in this case the angle that we have there. So what we can do, if you remember, this and that will cancel, so I'll remain with tan squared theta plus sine squared theta. So you can really see that the right hand side is equal to the left hand side. So this is equal to the left hand side, hence you have proved that. Watch out for another video where I'm